Impacts create even more fragments, which create more collisions, and more debris, and even more collisions. The process feeds itself, a chain reaction. One collision becomes 10, 10 become 100, 100 become thousands. Eventually, entire regions of orbit could become so dangerous that operating spacecraft there becomes nearly impossible. For years, this remained mostly theoretical, a worst-case scenario, an unlikely future, something scientists discussed but didn't expect to happen anytime soon. Then, reality started providing warnings. In 2009, two satellites collided in orbit. One was active, the other was no longer functioning. The impact created thousands of pieces of debris. Suddenly, the nightmare scenario wasn't just theory anymore. It had happened. And every year since then, the number of satellites has continued increasing dramatically, especially with the rise of private space companies. Today, thousands of new satellites are being launched. Massive satellite constellations are being built. Entire fleets of spacecraft now circle Earth. And while these systems provide incredible benefits, they also increase congestion. More satellites mean more opportunities for accidents, more opportunities for failures, more opportunities for collisions. NASA understood this challenge. Scientists believed improved tracking systems would help. Better technology, better monitoring, better coordination, and for a while that seemed reasonable. But space activity began accelerating faster than many expected. The orbital environment became increasingly complex, and some experts started asking a troubling question. What if cleanup efforts can't keep pace with the growing problem? Because removing debris from orbit isn't easy. In fact, it may be one of the most difficult engineering challenges humanity has ever attempted. Think about it. Imagine trying to catch a baseball. Now imagine catching a baseball traveling faster than a rifle bullet. Now imagine doing it hundreds of kilometers above Earth. That's the challenge engineers face. Several solutions have been proposed. Some involve giant nets designed to capture debris. Others use robotic spacecraft. Some concepts involve harpoons. Others rely on magnetic systems. There are even proposals involving powerful lasers. The goal is always the same: remove dangerous objects before they create new collisions. The problem is scale. There isn't just one piece of debris. There aren't 100. There aren't even 1,000. There are millions. Cleaning up orbit is like trying to remove every grain of sand from a beach while new sand continues appearing every day. And every launch adds more objects to the environment. The challenge becomes larger and larger. But the danger isn't just theoretical. If orbital infrastructure becomes significantly damaged, the consequences could be felt across the globe. Imagine losing reliable GPS. Navigation systems begin failing. Transportation becomes more difficult. Shipping networks experience disruptions. Communication systems become less reliable. Weather forecasting becomes less accurate. Disaster response efforts become slower. Financial transactions become more vulnerable to interruptions. Many of the systems that quietly support daily life depend on satellites. Most people rarely think about them until something goes wrong. And that's why scientists continue sounding alarms. Not because collapse is guaranteed, not because disaster is inevitable, but because prevention is easier than recovery. The earlier the problem is addressed, the better the chances of success. What's fascinating is that humanity has faced similar situations before. We've polluted rivers, we've polluted oceans, we've polluted the atmosphere. Often, we don't fully recognize a problem until it becomes serious. Space may be following the same pattern. The difference is that cleaning up orbit could be far more difficult than cleaning environments here on Earth. Every mission requires. NASA didn't tell us this because they thought they could fix it. What if I told you that one of the biggest threats to humanity isn't hiding deep in space, but is already surrounding our planet right now? And what if NASA knew this problem was coming decades ago? Not because they were trying to hide a secret from the world, but because they genuinely believed they had enough time to stop it, enough time to develop solutions, enough time to stay ahead of the danger, enough time to fix everything before anyone had to worry. But what if they were wrong? Because today, Scientists are becoming increasingly concerned that this problem is growing faster than humanity can control it. And if it continues unchecked, the consequences could affect nearly every person on Earth. This isn't a story about aliens. It's not a story about asteroids. It's not even a story about climate disasters. It's something far closer, something already orbiting above your head. And by the end of this video, you'll understand why some experts believe we may be approaching a critical turning point. For most of human history, the sky represented freedom, an endless frontier, a place untouched by civilization. Then, everything changed. In 1957, humanity launched its first artificial satellite into orbit. A new era began. Since then, we have sent thousands of objects into space. Satellites that help us navigate, satellites that forecast storms, satellites that allow phone calls to travel across continents, satellites that connect the internet, satellites that help military forces communicate. Today, modern civilization depends on them more than most people realize. Take away satellites tomorrow, and the world would immediately feel the impact. GPS systems would become unreliable, airlines would face serious challenges, global communications would suffer, financial networks could experience disruptions, emergency services would lose critical infrastructure. Much of the technology we take for granted depends on a network of machines silently orbiting Earth. But every launch created something else, something far less useful: debris. At first, nobody paid much attention. After all, space is enormous. What could possibly go wrong? For years, old satellites were simply left behind. Rocket stages remained in orbit. Fragments from missions continued circling Earth. The problem seemed insignificant, but over time, the number of objects grew and grew and grew. Eventually, scientists began noticing something disturbing. Earth's orbit was becoming crowded, very crowded. Imagine a highway where cars never leave. Every vehicle that breaks down stays exactly where it is. Every accident leaves pieces scattered across the road. New cars continue entering every day. Eventually, traffic becomes dangerous. Now imagine those vehicles traveling at more than 27,000 kilometers per hour. That's essentially what's happening in orbit. And that's where NASA's concern began. Scientists realized that even a tiny object could become deadly. A screw, a bolt, a fragment of metal no larger than a coin. At orbital speeds, even something small can strike with enormous force. The energy released can be comparable to an explosive impact. Suddenly, space debris wasn't just clutter, it was becoming a serious threat. NASA started tracking objects. At first, there were hundreds, then thousands. Today, there are tens of thousands of large objects being monitored. But that's only part of the story, because experts estimate there are millions of smaller fragments that cannot be reliably tracked. Millions, invisible hazards moving faster than bullets. And that's when scientists began considering a terrifying possibility. A scenario that would later become known as the Kessler Syndrome. The concept sounds simple, but its consequences could be devastating. Imagine two satellites collide. The collision creates thousands of fragments. Those fragments spread through orbit. Some eventually strike other satellites. Those advance technology. Every operation costs enormous amounts of money. Every mistake carries significant risk, and time continues moving forward. Meanwhile, the number of satellites keeps increasing. Every year brings new launches, new projects, new ambitions. Humanity's future clearly includes space, future communication systems, future scientific discoveries, future exploration missions, perhaps even permanent settlements beyond Earth. All of these dreams depend on maintaining safe access to orbit. Without that access, progress becomes much harder. That's why many experts believe this issue deserves far more attention than it currently receives. Not because catastrophe is certain, but because the decisions made today could shape the future for generations. So did NASA hide this danger? Not really. The information has existed publicly for decades. Researchers have published reports. Scientists have given warnings. Engineers have discussed potential solutions. The challenge wasn't secrecy. The challenge was awareness. Most people simply weren't paying attention. After all, space debris isn't something you can see from your backyard. It's easy to ignore, easy to forget, until the consequences arrive. Today, however, awareness is growing. Governments are paying attention. Private companies are investing in cleanup technologies. Scientists are developing new strategies. Progress is being made, but the race is far from over, because the problem continues growing, and nobody knows exactly how much time remains before certain regions of orbit become significantly more difficult to use. Maybe humanity will solve the challenge. Maybe new technologies will transform orbital cleanup. Maybe future generations will look back and wonder why anyone was worried. But maybe this moment will be remembered as the point when humanity finally recognized the seriousness of the threat. A threat that wasn't coming from another galaxy. A threat that wasn't heading toward Earth on a collision course. A threat created by humanity itself. Thousands of kilometers above our heads, right now, as you watch this video, countless satellites are orbiting Earth, helping power the modern world, helping billions of people communicate, navigate, work, learn, and live their daily lives. But surrounding many of those satellites is a growing cloud of debris, silent, invisible, moving at incredible speeds. A problem NASA hoped could be controlled, a problem scientists are still fighting to solve, and a problem that may ultimately determine how far humanity can go into the future. Because the question is no longer whether space debris is dangerous. The real question is whether we can solve the problem before it reaches a point where solving it becomes far more difficult. And that answer may shape the future of space exploration for decades to come. If you enjoyed this video, don't forget to subscribe, leave a like, and turn on notifications, because some of the most important stories about humanity's future aren't happening on Earth, they're happening high above it.